Hi guys, in this video I want to talk about a use case that we have, which governments generally use, but other people do as well. And that's when you're looking at a bit of the city, you want to understand how to fit more housing or floor space into that bit of the city. And so normally what you do is you take a look at the regulations that control what can be built on each one of these parcels. And they're around the world, normally two major ones. There's a zoning, which means that this can be residential and that can be commercial. And there's a floor area ratio or a floor space ratio, which is a multiple of the site area. So if an FSR is 1, you're allowed to build 1 square meter of building for every square meter of floor. Of site rather. So 1 square meter of floor for every square meter of site. So you can imagine if your building takes up half the site on an FSR of 1, it can have 2 stories. Or if it takes up the whole site, you can have 1 story. You can have big FSRs, like a really dense urban center would have an FSR of about 10 or 14. And you can have really low ones, like a suburb is normally 0.4. And so the job, or the approach is you select the sites that you want to fit the new housing in. And normally that housing target is coming from above, say like very high level, like the demographics of the nation are unfavorable, therefore we need more immigration, therefore we need more houses. Or the population is growing, regardless of policy decision, therefore we need new houses. And housing affordability is a problem, or key worker accommodation is a problem. We just need new houses. But where they go becomes really complicated, because it's not good enough just selecting all these sites and saying, all right, upzone them, give them extra FSR. It used to be, say it was 0.5, make it 1. That doubles the amount of permissible floor space that can be built. But on a lot of sites, there's other controls that prevent, so if you have heritage, so let's bring in the heritage actually. You've got heritage controls. That can mean that sites which may have free or excess FSR can sort of not be developable. And you can see heritage kind of salted and peppered. There's heritage trees and salting and peppering through these sites. So this site may be an old house. You can't just demolish and build new. There's other constraints, often strata. If a site is owned by 10 people or 10 entities and you need a majority of them to agree to redevelop it, that becomes much more difficult than if you're dealing with one entity. So the ownership of the sites, pollution, acid sulfate soils, asbestos, proximity to, there's a whole number of factors. So normally what you do is, in actually choosing or identifying how much additional housing can be provided, you have to do the sieve, and then you multiply the remaining sites by the upzoned FSR. And that only gets you half the way there, because if you're relying on the market to deliver the housing, then you need to run another overlay, which is, okay, these sites are permitted, like there's additional FSR permitted, but is the market actually going to build it? Is the price of the land, the price of the finished development, the cost of capital, the cost of construction, are all those variables connected in such a way that this housing will be delivered by the market, because there's enough profit there. All right, long preamble, but that's sort of, a lot of what urban policy is. It's a major component of urban policy directing this growth. And you can imagine the other considerations. Is this place serviced? Is there enough power? Is there water? Is there enough community infrastructure? Like if we have an extra 10,000 people here, is there a place for a school? Or can we upgrade the school? So there's, all of these other kinds of considerations as well. But I'm just going to focus on how to do that capacity study. And depending on the scale, you normally use a GIS. Like you said, 2D, we're going to chuck it into Q. And so here I've got QGIS, and here's the sites. I downloaded them. This is Newcastle. I downloaded the sites from the New South Wales Clip and Ship service, which is just awesome. So you clip it, they ship it via email to you, and I open it in QGIS. And then what I just had open there is the attribute table. So every parcel has some attributes: CAD ID, lot number, plan numbers, etc., etc., etc. Like, is it freehold? What is it? And so the approach that you would normally do is you would get your GIS person, or you would use GIS to apply the filters. So figure out if stuff is heritage. So I've just created a heritage column which has like a 1 or a 0 if it's heritage or not, and then get the FSR column, and I've just used a random number to do the FSR. And I'll add a new column just to show you how you do this. So what you do is a case when, what I'll say is when the CAD ID is divisible by 3, so when CAD ID mod 3 is equal to 0, then we'll say that it is strata. Else we'll say it's not strata. And I'm using 1 for true, so let's name this thing. So when strata is 1, that means it is strata titled, and when it's 0, it's not strata titled. And I'm using that because in Giraffe, our analytics only works with numbers. It does maths. It doesn't do if text. It only does, multiplies by 1 and 0. So it's a bit of a hack here, but it is useful. So case when CAD ID mod 3 is 0, then 1 else 0 end. And let's see if my memory is correct. We should see a new field appear here, and it should have at least some new fields. Okay, strata. Oh, not that one. Strata. Let's go just to our selected features. There it is. Okay, cool. So I've got these strated features here, so you can see when it's divisible in CAD ID. Well, there's a distribution of 1s and 0s. Hopefully it's the one I intended, but it very well may not be. But for our purposes, we've got a heritage, an FSR, and a strata parameter. And I've just used field calculations to get them. The actual way you'd get them in practice is you would do a join on the heritage shapefile, the FSR shapefile, and the strata shapefile. Or you would somehow acquire that attribution in a different way. But that can be a subject for a different video. Okay, so I'm just going to save out this selection, save selected features as. I'm just going to save them as a GeoJSON. I'll just chuck them on the desktop. Strata added, save, and it'll just add over here. Okay, and then I'm actually going to do a subsection because, so if I select all of this stuff, I think we've got, can I select? How do I select? Select features, yes please. Okay, and I'm going to do this on strata added, refresh. CAD ID, there we go. Count, I've got 751 features, which I'm going to load into Giraffe as project features. So they're not going to be a layer, because a context layer in Giraffe, they're going to be actual Giraffe project features, which means I'm going to be able to do analytics on them. But 751 is too many, so I'm going to select a subset of this. So I'm going to select by polygon, and I'm going to select along my corridor, which I will say is these sites along this little area here. How do I finish? There we go. Okay. And maybe even that's too many. So let's just try that. Let's just do this. Okay. Now I'm going to export these. So I've got 136. You know what? If I do 100, I don't even have to use my secret parameter to upload them into Giraffe. So I'm going to do that. The subject of this video is selecting sites. There we go. I've got 74 features, and if I open the attribute table and just look at what we've got these values 0, 3, 0, 1, so we can do some calculations. All right, so now I'm going to save these, save selected features as strata export, and I am going to export them as 4326, which is what I want. And I'm just going to make sure this is coming on the desktop, save, okay. And I'm going to say, okay. Now, I don't know what's going on here. You don't normally get this. I've somehow created some random CRSs, but I think it's going to work. Okay, and so there's my exports as a GeoJSON. And with that, we can jump to Giraffe. And in Giraffe, what we're going to do is upload that file. So I am going to add a layer, and I'm going to create my own. Actually, let's save this project first. Save project. Go to project. And at least we're somewhere. Okay. And now I'm going to add a layer to this project. I'm going to create my own via shapefile, and I'm going to browse, strata export GeoJSON. There it is. Okay. Now if I turn off all this stuff, I should be able to see them more clearly. There they are. And I'm going to import these to the project. Import them to the project. Because I don't want them to be a layer, I want them to be giraffe geometries. And if you click on them now, we can see I've got my FSR, my strata, and my heritage per parcel. And so now what I can do is I can open up my analytics, and I can start with a blank slate, and I can say capacity, create that category, and then I'm going to say I'm going to add a measure, and I'm going to say total additional capacity in square meters, and I just do this. So we go area in meters, FSR, and we go strata, and we go heritage, and then we go A, so the area times the FSR times. Now if heritage is true, we want this thing to zero out, so we go 1 minus D. So if heritage is true, which is a 1, that 1 minus D term is going to be 0. And then we do a similar thing with strata. So if strata is a 1, we want this thing to zero out, so we do 1 minus C. So if strata is false, then 1 minus C is 1, so we just get identity, just multiply by 1, otherwise we multiply by 0, then we add it all up. So we're going to save changes. And now nothing's happened because there's no features, because these little guys don't have a usage, so we need to give them a usage, and I'm just going to say region. And now something has happened. We've got 37,000 square meters of capacity. But that is not the additional capacity. There I've just multiplied A times B, so gross area times FSR. So what we should do is we should have an existing and a new FSR. So what I'm going to do is I'm going to create a new property, and I'm going to call that property new FSR. I'm going to set it to, I'm just going to save that for now. I'm just going to set it to 5. Okay. And now what we could do is we could do total additional capacity is actually, and let's add that at new FSR. And we want to actually multiply by the difference between the old FSR and the new FSR. So we go F minus FSR minus B. And save those changes. So there's an additional 63,000 square meters possible with these sieves, with the heritage sieve and with the strata sieve, if we set those FSRs to 5. And we can override, like we could say, actually these guys, instead of an FSR of 5, let's make the new FSR 10. We'll go up to 76,000. So now we're actually playing. Now we're zoning, we're rezoning, and we're seeing this capacity study kind of happening live. So there's more we can do, more that we can do. And the way we can do more is by creating a usage. So I'm going to grab everything. I'm going to delete this new FSR. Okay, that deletes that because new FSR missing for everything. And what I'm going to do is in the usages, I am going to go to my region, and I am going to clone this, and I'm going to say FSR 3, and I'm going to add a property called new FSR and set that equal to 3. Now, and then I'm going to save. Let's change this color, and I'm going to say this color is like a that. And I'll also add another property called height. And we're going to say that this FSR3 has a height of 14 meters. Then I'm going to clone this and call this FSR5 with caps. And all I'm doing here is I'm hoisting the properties from the object to the usage level. So make this a bit more of an orange. We'll put the height up to 22, and that FSR 5 has to be 5, and we'll save changes. And we'll just do one more called FSR 8, and we'll make it a vivid purple, and set that FSR to 8, and set that height, maybe this is 44. Save changes. Okay. Now, we should, with luck, be able to select these things and assign a usage called FSR3. Okay, great. So if we set everything to FSR3, we're going to get an additional capacity of 22,000. But now, and you can see it inherits now. There's a problem. There's a problem. We've got a color override. So I set my FSR3 to a beautiful yellow. But this is coming out as gray because on these objects there is a color, a line. I'm just going to delete all of those. We don't want any overrides, no graphic overrides. And so now these things are inheriting the usage color. Now what I'm able to do is say, well, why don't we get these guys and set them to FSR 5. And that's annoying. I somehow get that color back, but I'll just delete it. You can see at least it inherits that height, and we've gone up to 28,000. And now I'll have the distinct displeasure of every time I change this, I'm going to get my, my graphics properties back. There we go. But now I've got my FSR 8, and the capacity's gone up to 47,000. And remember, that's including the sieve, because in this equation, we're sieving out by strata and heritage. So you can see here, when strata is false, heritage is false, we get a positive number. But if we get to this, strata is true here, and the resultant is 0 for that component. So remember with Giraffe, you can always check the results by flicking your way through and just double check what's going on. And similarly, like this, you can sort of fly around and see, make sure that everything's going good. Here, new FSR is 8, and that's 8. Jump across there, FSR is 3, because this is FSR 3. And so now we've got a really cool thing. We've got a height of building, we've got a color, we've got a graphic representation of what this thing may look like, and we're getting that total additional capacity. So quite a complicated equation, worked out pretty simply.